Guys, welcome to the notes on 6.3. We're going to look at elimination using addition and subtraction. So we've solved by graphing, we've solved with substitution, and now we're going to solve the third method is using something called elimination. What we're going to do essentially is we're going to add the two equations, and we're going to hope to eliminate one of the variables, which will allow us to solve for the other, and then we're going to plug that back in and solve for it. So here's what it looks like. Here's the steps, and I think the steps are important. Step one is absolutely the most important. You need to write the system so that the like terms and that the equal signs, that's not on here, but equal signs also, so that they are all lined up. That's step one. That's really important. Then we're going to add or subtract, which will eliminate one variable, solve the equation. Then we're going to substitute the value from step two into either one of the equations and solve for the other, and then write our solution as an ordered pair. Also important because we have to understand that we are solving systems, so our answer is an ordered pair. So let's look at the example that the problem gives us, or that the book gives us. So we have this system right here, 4x plus 6y equals 32, and then we have 3x minus 6y equals 3. Step one is done for us. They're all lined up. The equal sign is lined up, and you'll notice that right here the coefficients are opposite. So what we're able to do is we're just going to add the two equations. When we add 4x and 3x, we get 7x. 6y and negative 6y add up to 0, and then 32 plus 3 is 35. From here, we're going to solve the equation 7x equals 35, and we get x equals 5. Then we take this x equals 5, and we're going to substitute it back into either one of the equations. It doesn't matter which. The book substituted into the first one, so no big deal. And then we solve for y, so the solution is 5, 2. A lot of people like elimination. It seems to be the best, especially for students, especially when it's lined up like this one is. So go ahead and take a second. You'll notice that 1a is all lined up and ready to go. 1b is not lined up and ready to go, so you're going to have to rearrange this one so that x's and y's and equal signs are all lined up. Use elimination for both of those, and then unpause the video and check your answer. So go ahead and pause the video now. All right, you've unpaused. Hopefully for 1a, the answer you got was 0, negative 1. So x is 0, y is negative 1. And for 1b, hopefully you got 6, 1. Okay, 6, 1. So 0, negative 1. That was a little messy. And 6, 1. If you didn't, pause the video here, try those again, and if you still don't get them, remember to ask me about those in class and we will go over them. Number 2, example 2 shows us how to write and solve a system of equations given a word problem. So we're going to have to come up, we have negative 3 times one number plus 5 times another. This is just translating. We've been doing this all year. Okay, it's translating a word problem into two different equations, and then we're going to use elimination to solve. You can always check your answers. Okay, you can always check your answers by plugging 2 and negative 1 back in, and we should get 2 true statements like the book did right here. So let's go ahead and take a look at number 2. Number 2 asks us to, it tells us the sum of two numbers is negative 10. All right, so the sum of two numbers, that's in the way. The sum of two numbers is negative 10, and negative 3 times the first number minus the second number equals 2. Okay, so come up with your answers there. Come up with two equations. Pause the video. Pause the video. Come up with two equations. Unpause it, and we'll check our equations. Then we'll pause it again and come up with some answers. So go ahead and pause the video here and come up with your equations. All right, so here's the two equations I got. X plus y equals negative 10. And then negative 3x minus y equals 2. So those are the equations. If you didn't get those, make a note, and we'll talk about how I got those. Now you're going to solve for the variables. You notice the y's, everything's all lined up. The y's are opposite, so we're going to add down and see what we get. Go ahead and do that now and get your answer. Go ahead and pause the video and get an x and a y. All right, so let's see what we got. I got negative 2x equals negative 8. X equals 4, so y equals negative 14. So our answer as a coordinate would be 4 and negative 14 if we list it out as a point. But writing the two numbers, that's fine. Also, either way is good for this one. All right. So elimination by subtraction. So if we have, for example, if we have this problem, and you'll notice that a couple things. First, we're going to rearrange it so that all the numbers are lined up. So 2t plus, I hate using t's, plus 5r equals 6. Then we'll rearrange this one so we have 2t plus 9r equals 22. So you'll notice that we rearranged them, and the 2t, we have that on each, but they're the same sign. So what we're going to do is we're going to subtract. When we subtract, we're subtracting each term. So it's essentially kind of like the distributive method. We're going to apply a negative to each one of these. And that's what they did down here. When we subtract, you have to subtract each item, okay? Each item or term. You got to make sure you subtract them all. Once you do that, you solve, and then you plug back in. After that, it's the same old thing. It's pretty simple, okay? Go ahead and try that for number 3. Solve this. You'll see they're already lined up for you, so you just have to do the subtraction. Go ahead and solve number 3 right now. Pause the video here and try that. All right, you've unpaused. Hopefully, you got H. All right, hopefully you got H. The last example is a real world. Not surprising, we have real world examples on every unit we do. So this is just coming up with a system and then applying, applying solving systems using some form of method. Here we're going to work with elimination. So we had 850C for each of them, so we end up subtracting, making sure that we subtract each term, and then you get an answer for what was J. You plug that in, you get C. So Cheryl works 22 hours, Jackie works 15. No problem there. So let's do this. Let's try and get number 4 right here. So Tamara and Adelina, I'm assuming that is. They're throwing a birthday party for their friend. Tamara invited 5 fewer guests than Adelina. Together they invited 47. How many guests did each girl invite? Go ahead and pause the video here and come up with your equations, and then we'll work on solving them. Okay, pause and come up with your equations. So here's the equations I got. I got Adelina minus 5 equals Tamara. Okay, so Adelina minus 5 because Tamara had invited 5 fewer guests. Okay, so we take Adelina's amount, we subtract 5, we got Tamara's. Then I got A plus T equals 47. I can't start here because they aren't lined up. So I'm going to add 5 and subtract T from the first one. I'm going to make this A plus T equals 5. Okay, oops, sorry. A minus T. A minus T equals 5. Now it's all set up and ready to go. Go ahead and pause it here. And yeah, pause it here and find out how many each of them invited. Go ahead and pause the video now. All right, you've unpaused. Hopefully you have 2A equals 52. So A equals 26. So that's how many Adelina invited, which leaves 21 for Tamara. Okay? That's it. What I need you to do now, if you would please, let's take that, get rid of this, take this, put it up there just in case we need it later. If you could try 1 through 6 for me, make sure you're good at these, know how to do them. You try those, and we'll take questions on them in class. All right, see you next time. Bye.